But let's continue. So I was explaining about this new formula that I'm going to introduce to you. So it's f prime. So this prime simply means that we are now differentiating. We are now differentiating the formula. This is the same as a gradient. Like I told you, this is the same as the gradient. So, but it's now indicated as f prime. The prime simply indicating that we are now differentiating so that we get a gradient. So, and to differentiate, we no longer use this formula of the gradient. We are using a new formula of limit when h approaching 0 given by an argument of f at x plus h minus f of x divided by h. So there is a new symbol that I'm introducing here. So I'm going to explain that symbol to you. So let's just assume we're given a straight line like this. And on this straight line, we have a point given as x or a variable. For sure, this variable can be standing for different values there. So, and on that variable, we add x plus h. So this is called a step size. The h that we have there is called a step size. Ndizvi talutshedza nga Tshivenḓa ariri maybe ṱhamusi ndi hafhanoni ndi khou ṱoḓa u tshimbila to certain direction, there are steps which I'm supposed to take, and these steps can be measured. The distance between my two legs can be measured. So, and these steps, we have called them step size. Is this h, is the h that we have there. So we have x, and then from that x we add by step size. So now if we are having x here and we substitute into the function, we are going to get f of x. We're going to get, we substitute x into the function, we'll get f of x. And now if we substitute x plus h into the function, we will now get f of x plus h. So that is the function that we have here. So now let's investigate. If this h approach 0, what's going to happen? If this h approaching 0 is going to 0, you can see in this case we are saying if h approaching 0, what happens? So you will be minimizing this distance between these. So let's say we started with h equal to 1, and we now reduce h to be 0.5. So it means this distance in between these two values will be decreasing like this. When h decrease, the distance between x and x plus h decrease. And when the distance between x and x plus h decrease, it means even the distance between the functions here will be decreasing. And once that distance is decreasing, it simply means you will be approaching what is called the gradient. So, and that is simplified by this symbol, which is called the limit. So when this limit approaching 0, when limit of h approaching 0, what happens? We then get the gradient. So it's what is usually happen. When this distance decreasing, when h is decreasing, we now approach what is called the gradient, which is indicated by f prime x. So this is the formula that we're going to use. It's called the first principle. The first principle formula is this principle that we have here. So let me write the name of that function. First principle. So it's the one that we're going to use to solve these questions, or to find the gradient of these functions that we have there. So now let me do an example so that you can see where is this going. Example. Find f prime x by using first principle. By using first principle. How do we deal with this situation? We want to find f prime x. What did I say is f prime x? If you remember, f prime x is what?
The gradient.
Is the gradient, yes, don't forget that. F prime x is the gradient. So we want to obtain the gradient by using what? by using the first principle. What is first principle? First principle is this formula. Are we all together?
Yes.
All right, so we want to find the gradient of first principle given a function of f of x equal to x squared plus 1. We want to calculate the gradient of this function. We are not given coordinates in this case. We are given a function. A function is like this straight line that we have here. So we want to find the gradient of this straight line. But you can see here we want to find the gradient of a parabola graph. That's what is interesting about this method. Instead of finding the gradient of a gradient of a straight line only, with this method you can be able to find a gradient of a parabola, a graph of cubic function, which I'm going to discuss with you some other day. It's under this chapter of calculus. Just keep in mind that by using this method, you can be able to find a gradient for different functions. It's the same as average gradient. If you remember, it's the same as average gradient. So let's find the gradient or the f prime x by using the first principle in this case. Having given the function f of x equal to x squared plus h. So let's implement that by using that formula. We're going to have f of f prime x equal to limit when h approaching 0 of f of x plus h minus f of x all divided by h. So now what we are left to do there is to represent the f of x plus h and f of x. But f of x is given already from that question. Can anyone of you tell me what f of x is equal to from this question that you are dealing with? F of x is equal to
X squared plus 1.
X squared plus 1. That is given. It's a given knowledge. So now from f of x, we can obtain f of x plus 1. That simply means wherever we have x, we are going to add h. So it's what we're going to do there. So here we have x, so it means we can add h next to x squared plus 1. Let me explain this part again. Why are we doing this? We want to find this f of x plus h. Already we have f of x. From f of x, we want to find f of x plus h. How can we find f of x plus h? Next to variable x, we just have to add an h. So if we add h next to x here, we're going to have f of x plus h. And next to this x here, we add h, we're going to have x plus h all squared. This squared is this one that we have there, and then plus 1. So just by doing that, you now have f of x plus h. Are we together?
Yes.
All right, wonderful. So now let's substitute this information on that formula of first principle. First principle is this formula that we have here, f of x plus h minus f of x all divided by h. Then now let's substitute what we have there. If we substitute on that formula, we're going to have limit when h approaching 0 of, where we have f of x plus h, we now substitute x plus h squared plus 1 minus, and then where we have f of x, we substitute x squared plus 1, and then all this divided by h. So we are now left with simplification. We just have to simplify that and see what we obtain. So we have limit when h approaching 0. X plus h squared is the same as x squared plus 2xh plus h squared, and then plus 1. This plus 1 is the one we have outside this expansion. Then the negative, it can multiply throughout. And when it multiplies throughout, we're going to have negative x squared minus 1. All this divided by h. So from there, we have like terms. So limit when h approaching 0 is you keep it until the last step. You will see what we're going to do with this limit when h approaching 0. So we now add the like terms. These and that, they will cancel each other. When we add these two terms, we are going to obtain 0. 1 and minus 1, when we add them together, we are going to get 0. And I can tell you that all the terms we have on this bracket, they must cancel with the terms you obtained here. Otherwise, if they don't cancel, there's a problem. So this, it cancels with that. And then 1, it cancels with -1. So it means you're going to be left with 2xh plus h squared, all divided by h. After adding the like terms, the numerator is going to be in that form. I can tell you without any hesitation that the h we have on the denominator, it must cancel with the like term on the numerator. Otherwise, if this h does not cancel, we have a very serious problem. So let's see if h can cancel with a term on the numerator. We still have limit when h approaching 0. We can take out the common factor of h here. When we take out the common factor of h, we'll be left with 2x plus, and then when we take out the h as the common factor, we'll be left with h. All this divided by h. Therefore, h and h, they cancel each other, right? So it means we'll be left with limit when h approaching 0 of 2x plus h. So that is your function. But limit in this case is approaching 0. So when h is approaching 0, on the last step, it simply tells us that we need to substitute this 0 here on the function. So we can, wherever we have h, we can now substitute 0. And once we do the substitution, you no longer write the limit. You no longer write the limit. So it means you are going to have 2x plus a 0. And then the final answer is going to be 2x. Your 2x is the gradient that we were looking for. So it's the average gradient. It's called the average gradient. So we find the average gradient by using the first principle formula. Are we together?
Yes.
Wonderful. You must be able to get this right. It's very, very important question of the first principle. University mathematics starts here. University mathematics starts here. So you must know all these things that you have here. So I've introduced the first principle. At later stage, I'm going to introduce a differentiation, differentiate by using rule. And differentiate by using rule, we must get exactly to the same answer that we have done there. Can I do a second question and then you will try third question?
Yes.
All right. So let me rub this function here, and we use different function of 2x squared minus 2. That is the function we're going to use. So we are answering the same question. Find f prime x, average gradient, by using first principle. First principle is this formula, and the function that is given is that one. So now let's try to answer that question by using the first principle. At all time, f of x will be given. We have f of x equal to 2x squared minus 2. So from f of x, you must obtain f of x plus h. Can you tell me f of x plus h if we are given f of x equal to 2x squared minus 2? What is f?
2 times x plus h squared.
Yes. Minus 2, right? So now, before the substitution, you can decide to simplify further so that you don't simplify on the formula. So let's simplify this f of x plus h. So the simplification of f of x plus h is going to give us x squared plus 2xh plus h squared minus 2. And then these 2 we have here is multiplying everything inside the bracket, but it's not multiplying -2. So take note of that. So when it multiplies the first term there, we're going to obtain 2x squared. When it multiplies 2x squared, 2xh, we're going to obtain 4xh. And when it multiplies h squared, we're going to have 2h squared minus 2. So we don't have like terms here. What is this? This is your f of x plus h. So it's the one we're going to use on the first principle formula of f prime x equal to limit when h approaching 0 of f of x plus h minus f of x, all divided by h. So where we have f of x plus h, can any one of you tell me what we are going to substitute? Where we have f of x plus h, what are we going to substitute?
The 2x squared plus 4xh formula.
Yes, true. So we have to substitute that where we have f of x plus h. So the other thing which is very important is this negative here. You must be very careful about that negative. Usually, when we are on this step, we have to put a bracket like that. And then from there, we substitute your f of x, which is given as 2x squared minus 2. All this must be divided by h. You are now left with simplification. And I told you, at all time when we deal with this question, this h that we have on the denominator, it must cancel with the term on the numerator. Otherwise, if it does not cancel, when we substitute the limit, we're going to have a problem on the denominator because we'll be substituting a 0 where we have h. And then if a denominator is 0, we have undefined. So this h we have here, it must cancel with other term that we have on the numerator. Is that okay? Are we together?
Yes.
All right, wonderful. So this negative, it must multiply throughout, and we will then obtain limit when h approaching 0 of 2x squared plus 4xh plus 2h squared minus 2. Then the negative, it multiplies throughout, and we obtain minus 2x squared. And then this negative, it changes to be positive because we are multiplying negative with negative. So we end up having a positive, and we divide throughout by h. After having that, we now have to add the like terms. And I told you, all the terms that we have on this f of x, it's a must that it must cancel with some terms that we have on this f of x plus h. So you can see minus 2x squared from f of x is canceling with this term here. So this term cancels with that term. And the 2 that we have here, it cancels with the 2 there. So after adding the like terms there, can you tell me what we have on the numerator?
4xh plus 2h squared.
Yes, definitely. So that is your numerator, and this numerator we divided by h. Do we have a common term on the numerator?
Yes.
Let's take that common term. Can you tell me what's the common term on the numerator?
H.
It's h. It's 2h, but we don't have problem with 2. Therefore, let's just take h out as the common factor. And when we take out h as the common factor, we'll be left with 4x plus 2h, and all these divided by h. The reason for doing that is to make sure that the h on the denominator cancels with the h on the numerator, and we'll be left with limit when h approaching 0 of 4x plus 2h. We no longer have the denominator. Can any one of you tell me the last step that we're going to undertake after having that?
We substitute 0 on h.
We have to substitute a 0 where we have h because our limit is approaching, our limit of h is approaching 0 there. In some cases, it will be approaching different numbers. Fortunately, in this case, it's approaching 0. So where we have, let me also emphasize, on the first principle, it will always be approaching 0. But there are some questions after finishing with first principle that we're going to have where limit is no longer approaching 0. So you must keep that in mind. We'll do it at later stage after finishing this. So limit when h approaching 0, it means when we have h, we substitute 0. And once we substitute 0, we're going to have 4x plus 2. And then we substitute 0 where we have h. Therefore, the final answer that we are looking for is 4x. That 4x is your average gradient of this function that we are given here, of a function 2x squared minus 2. That is how we differentiate a function by using first principle. Is that okay?
Yes.
All right, wonderful. So now we are at a stage where I can tell you why this principle is important. That principle is important because from physics perspective, it connects what is called the displacement or the distance with velocity and also with acceleration. So now, when you differentiate the displacement, maybe by using first principle, the displacement in this case, let's say, is given by this function, f of x. So when you differentiate the displacement or a distance, you are going to get a velocity. So it means what we have done on the board, what you see on the board, we're having a displacement or a distance, which is f of x. And then by applying the first principle, what do we get? We get a velocity. Velocity is this function that we have down there. So we have a velocity. When we differentiate displacement, we get a velocity. So after having a velocity, it means we can find the second derivative, of which I'm going to do at later stage with you for finding the second derivative of this answer we obtained down there. And when you do the second derivation, what are you going to get? You're going to get acceleration. So calculus, it connects these three important variables from physics, displacement, velocity, and acceleration, of which I believe you know all the formulas from equation of motions, if you remember them. We have an equation for the displacement, for velocity, and for acceleration. So these three equations that we have here, they can be defined mathematically by this calculus, by differentiation. So now, are we together? Are we together?
Yeah.
Can I give you a question to try?
Okay.
All right. This is the question I'm going to give you to try just now. So I'm just rubbing off the function because that's the only difference with these questions that we have here. But we're starting with the simple ones. At later stage, we're going to do difficult ones. So this is just a start. Because in some cases, we may have trig functions which are difficult to deal with. And in some cases, we can have inverse functions which are difficult to deal with. So let's just start with these simple ones. Where the example I'm going to give you, we will be having x squared plus x minus 1. I want you to differentiate that by using first principle. And I'm giving you 5 minutes to attend to that question. So now it's your time to try and answer that question. When you are done, let me know. All right, this meeting is going to end in few minutes time. Make sure when it ends, you log into the new meeting using the same link. Is it okay?
Yes.
Yeah. So yeah, just log into the new meeting.